Hi everyone, my name is Yamila. I work as a security researcher at 11 Paths. 11 Paths is a Telefonica cybersecurity unit. The idea of this talk came to us because we usually think of SIEMs as defensive tools or blue team tools. And during this talk, we will see them from the point of view of the attacker or the red team. Yes, I came from Argentina, very, very long. It's 27 hours of, a trip of 27 hours to get here, so a very, very, very long trip. I think you might know my country for some of the things. Messi, who knows Messi? Raise your hand. Messi, all of you knows Messi, I know that. Dulce de leche? Anyone? No? Just one, three people. Next time I have to bring some dulce de leche for you to try. And asado? It's like Argentinian meat. It's delicious, it's great. Well, starting with the talk. SIEMs stand for Security Information and Event Management. SIEM solutions combine security information management and security event management. Security event management carries out log analysis of log data on real time to detect threat, I don't know, sorry. To provide event correlation, threat monitoring, and incident response. And security information management is used to analyze the log data in order to generate reports. Oh, this microphone is... Well, any of you know Splunk? Okay. Splunk is a SIEM solution that it has a web interface, and it can search, sorry, okay. Splunk is a commercial SIEM, that's important, that allows you to capture, analyze, and search for data within a web interface. Any of you knows the other one, Greylog? The open source one? Okay. Greylog is an open source SIEM. The use is like the Splunk one, used to search and monitor data with a centralized console. And it uses MongoDB and Elasticsearch in order to store and search for the data. Well, who uses this type of system, these SIEMs? In general, SIEM solutions are mostly used by large organizations and public companies. Compliance with regulations remains a very strong factor in the use of this technology. However, from the point of view of the attacker, this is the attacker, Hacker Cat. I love it, I love Hacker Cat. Well, the permission that SIEMs have on the server on which the SIEM is installed and the other components on the infrastructure are very broad. So you can use administrative access to a SIEM. It can be used to compromise the server on which the SIEM is installed, and in some cases, the client equipment from which the SIEMs collect the events. Well, we are going to talk a bit about Splunk versions and features. I can't see anything there, so I just look here. the 3 more important versions of Splunk, the most used. It's a light version, but it's not very used. So we are talking about Splunk Free, Splunk Enterprise, and Splunk Cloud. The first one, Splunk Free, don't have any type of access control or authentication. Any user who knows the URL, and it's not a very difficult URL, you can search in Shodan for that, can access with administrative privilege to the SIEM. Splunk Enterprise can use several authentication methods, like LDIP, proxy SSO, SAML, and scripting. But in general, username and password, that's a Splunk internal authentication method. It's the most used, and it's the default authentication method. In Splunk Enterprise, you could configure password policies. The only one mandatory password policy for Splunk Enterprise is the length of the password. It's mandatory to have a password from 8 or more characters length. In new versions, you can configure another things like password complexity, account lockout after a series of failed login attempts. But these password policies are not applied in the same way in all cases. So we are going to see that later in another slide. Well, about the permissions. Splunk Free and Splunk Enterprise are usually installed as root or with administration privilege. You can install it with an unprivileged user, but it's not the common case in general. And the important thing is in Splunk Free and Splunk Enterprise, you can upload custom applications, or that is to say, you can build your own application and upload to Splunk, application or script. Splunk Cloud is different because Splunk has all the control on the environment, so you can configure Splunk by changing configuration files, by the command line interface, and you can't upload custom applications and a script. And the authentication for Splunk Cloud could be SAML, user password, or LDIP also. Okay, Splunk Cloud, sorry, is usually published on the internet because, of course, it's Splunk Cloud. But why would someone expose to the internet a Splunk Free or Splunk Enterprise? I don't see any reason for that. You can search Shodan for Splunks. The first search is by HTTP component, and this search returns all the Splunks that have the web interface published on the internet. The second one returns all the Splunks that have the management port that is 8089. With Splunk D, you can search for all these Splunks on the internet. Well, that is the Splunk login page. Analyzing the source code of the Splunk login page, we notice that this is happening. To access the Splunk REST API endpoints, it's necessary to be authenticated first. But in this case, the Splunk login page, the API call is made directly from the Splunk login page before the authentication process. And the result is loading in JSON, as you can see. The first endpoint service session indicates with the property has logged in the top of the screen, indicates whether someone ever logged into the SIM. If anyone ever has logged to the SIM, it's very, very likely that the SIM still has the default password that is changed me. In older versions, in new versions, you can choose your own. From 7.1, you can choose another password at installation time. But in older versions, the default password was changed me. And in the other API call, that is, I don't know the name, I don't find it. It's service server info. This has the information of the Splunk license, and you can see there is if it's a Splunk free, a Splunk Enterprise, or a Splunk Cloud, and the version of Splunk. All this before authentication, just looking at the source code of the Splunk login page. With this information and the showdown search for all the Splunks with the web interface exposed to the internet, I wrote two Python scripts to detect Splunks at risk of being compromised because of default password or because they are the free version with no authentication. The first one detects all the Splunk free exposed to the internet. And the second one detects all the Splunks with default password, previous version to 7.1 that has no more default password. The result is this. 669 Splunks exposed to the internet at risk of being compromised for default password or because they are the free versions of Splunk who has no authentication. Well, but what's the case if the Splunk that we are going to attack is not free and it has not the default password? You can do a brute force or dictionary attack on the password of the user admin. In previous version was admin. Now you can choose another name for this user if you want, but in most of the time the user is still admin. The Splunk brute force or dictionary attack could be performed on the web interface or in the management port. You could use, there is a Metasploit to carry on this attack, and you can use other tools such as Hydra on the web interface. But the problem is, in newest version, you can configure account lockout, but a series of failed login attempts. So our approach is different. We made the brute force or dictionary attack on the management interface, not on the web interface, because the account lockout policy doesn't apply to the management interface. You can try all the password that you want, and you won't be locking the admin account. Well, I will explain attack vectors 2, 3, and 6 because you are going to see the others in the demos that I brought today. Number 2, being a log analysis and collection, the first thing that we can think of is use it as an intelligence source to identify users in the environment, roles, and usage patterns. That's attack vector 2. For attack vector 3, you can use the Splunk functionality that uploads files to indexes to read any file from the server where Splunk is installed. For example, the shadow file on Linux systems. And attack 6 is deploy malicious applications to universal forwarders. Well, Splunk has a functionality called deployment server. This functionality is used for deployment of applications and configuration in distributed environments, and also for configuration of the Splunk universal forwarders that are the Splunk collection agents. The agents installed in the clients, like in the database server, in the Active Directory server, for collection of information from routers or firewalls. About the applications, it's very easy to create Splunk applications. Splunk provides a template called barebones that builds the entire structure. You only have to worry about the directory bin. The directory bin is the directory which contains the actual code of the applications or script. And these files, the file app.conf, this file contains all the information of the application configuration. I forgot to say this. Splunk has native Python support, so you can build applications in Python, Perl, Bash, PowerShell, and even an executable file. All that could be application or scripts used in Splunk. Well, Splunkbase. Splunkbase is like the Play Store in Android. It contains applications designed by Splunk or by different providers to integrate their products with Splunk. Here, the list is ordered by the most downloaded applications on Splunkbase. You can see the most used applications are for Windows, Linux, Cisco, database. Most of these applications require credentials to connect to the device they monitor. And these credentials are stored in Splunk. And if we have admin access to Splunk, we can access this credential and decrypt it and use in our attack to compromise other systems in the infrastructure, not just the Splunk server. Well, now we are going to see the demo of the attack vectors 1, 4, and 5. First, I will perform a brute force or dictionary attack on the admin user of Splunk, and then obtain all the Splunk stored password of the applications. Okay. At first, we are going to scan the network in order to detect SIMs active on that network. The tool detected two SIMs, 2 Splunks. Now we are going to choose the last one in order to attack it. and launch the attack module. First, we need to use the option 1 because we need the credentials. That's the brute force or dictionary attack. Now that we have credentials, we can use the other attacks. We are going with option, I think is 4, to obtain all the Splunk applications credentials. We need to use the credentials that we obtained before. Okay, and that's the credentials stored on this Splunk. It's the last version of Splunk. The first one is are the credentials used by Palo Alto firewall in order to administrate the firewall. And the second one is the account used for LDIP binds. This account generally is a privileged account because it's used for obtaining the logs of all the Windows hosts on the infrastructure. So generally, it's a very privileged account, and for the attacker, it's a very important account to have the credentials for. Well, now we are going to install a malicious application to obtain a reverse shell from the Splunk server. We are going to attack the same SIM as before. Launch the attack module. And in this case, we are going with option 7, upload malicious app to Splunk server or universal forwarder. It could be used on both the server or the universal forwarder. It's a Linux Splunk server in this case, so we are going with option 1. We need to enter the credentials and our local IP address for receiving the reverse connection. The application is already installed, our shell, and we are going to start a listener on port 1, 2, 3, 4, 5 in order to receive the reverse connection. Now we have to wait a few seconds, and Splunk will connect to us. That's it. Splunk connect to us with a root privilege. The application that we install in this case is a Python reverse shell because it's a Linux server. On Windows universal forwarders, you can't use Python, and you need to use PowerShell or another a BIT file or another payload. This tool is developed by us in 11 paths. Okay, recommendations for hardening Splunk. First, we need to install Splunk, the server and the universal forwarders with unprivileged users. Change all the default password, of course. Use another authentication method, not Splunk internal, and if it's possible, a second authentication factor. Use TLS. Please don't use Splunk free in production environment. I see so many Splunks free in production environment. I think it's because the cost of Splunk and all that, but please, it has no authentication. It's the worst. Don't expose the Splunk server on the internet, of course, except cloud that you need to put it on the internet. And disable the web server if there is no need. Most of the attacks to Splunks are based on the web server, so it's an attack surface reduction, disable the web server when you don't use it, update and patch Splunk in a regular basis, and enable a Splunk audit is the index_audit. Now, we are going to talk about Graylog. Same case as before. Who published the Graylog web interface on the internet? I don't see any reason. No, there is no Graylog cloud or something like this, so it's, I don't understand this. The most important Graylog components are MongoDB, Elasticsearch, the web interface, and the REST API. The attack vectors. You will notice that the attack vectors are different. This is because Graylog does not allow us to upload code through the web interface. So you just can customize inputs, outputs, and alerts. So we need to use other attack vectors different than the Splunk ones. The first one is the brute force or dictionary attack. In order to perform this attack, we need to do a post request to this URL, API system sessions. The username is admin. You can change it. And accounts are not logged out for failed access attempt. That's attack vector number 1. You can configure it. It has the policy for configuring the logout is not there in Graylog. Well, Graylog virtual machines appliances. Graylog virtual machines appliances, OVA or AMI, has those passwords by default. The first one for the web interface is admin, a very difficult combination of username and password to guess, and Ubuntu for the console. And additionally, in Graylog virtual machine appliances, Elasticsearch, MongoDB, and the web interface are listening on all the interface. I think that's the reason that why there are so many Graylogs exposed on the internet. I think it's not intentional. It's people that just install the virtual machine appliance and didn't notice that it's going to publish these ports on all the interfaces. As attackers, we could test those default credentials to see if they are valid. That's attack vector number 2. And same case as Splunk. Graylog store credentials, but